Hey guys, today's lesson is about comparing distributions. What we're going to be looking at is um, choosing the right measures of center and spread based on the form of the data. You'll see what that means in a second. Um, let's take a look at the three measures of center. Um, in a lot of the questions that you have done when we studied these things, you were just asked to find all of them. But in practice, you probably wouldn't use all of them to describe your data. You would choose the one that's the most valuable to you because each has a series of advantages and disadvantages. For example, the mean is very easy to understand and calculate, but a huge disadvantage of using the mean is that it can be very distorted by outliers. Whereas the median is not affected by outliers. But there are other disadvantages here, like it needs to be sorted. So let me give you an example here. If you want to calculate the average household income in Australia, if you use the mean, you don't really get an accurate picture of what the average household income is because the mean gets very heavily distorted by people at the higher end of the scale. The median is a much more accurate measure of center in a case like this, average household income, because it doesn't get affected by the very small percentage of very high income earners that do affect the mean. That's just one example of why you would choose median over mean. But I would like you to get this table copied down in your books with all the advantages and disadvantages of all three. And the other ones we're going to look at are range and interquartile range and standard deviation. We're not going to worry about standard deviation because it's something we've not really looked at in our course. But the range and interquartile range have sort of similar benefits and disadvantages, with one key exception is that the interquartile range is another one of those ones that aren't really affected by outliers. But it has a big advantage in that you need to sort your data in order to find an interquartile range. Let's look at just a quick example. So we've got a number of participants in two different fitness classes, and we're going to calculate the mean and median for each set. So mean for Beck. I've already done this before I started recording. If you add up all those numbers, it's 42. And there's seven different classes, one each day. So the average here is 6. And mean for Rita is, she has 64 participants in her classes. So her mean is about 9.1. Now, to calculate the median, we need to put all the scores in order. And for Rita, 10, 10, 12, 14. It's a bit hard to... Sorry, I should have spaced those out a little more. So the median, there are 7 sets of scores here, days of the week. So the median is going to be the 4th one. Now we're looking for the range and interquartile range. So the range here for Beck is just 8 minus 4, 4. And the interquartile range is 8 minus 4 again. And over here for reader, we have 14 minus 1 is 13. And the interquartile range is 12 minus 8, or 4. That's just a little bit of revision on calculating mean, median, range, and interquartile range. But something we want to really focus on for this lesson is examining what we've calculated here, and is there anything that concerns us a little bit? And the main thing I want you to notice here is this. Rita's class on Sunday only had 1 attendee. Every other day she was between 8 and 14 attendees. So this particular score significantly impacts all those statistics we just calculated, except for the median. Because if you ignore the Sunday class, her mean participation goes up from 9.1 all the way to 10.5, which is a pretty significant increase. If you ignore the 1 here, the range becomes 6, not 13. So you can see that the just one outlier can have a fairly significant impact on certain summary statistics. So you guys are going to look at a few examples. Again, there'll be a little bit of revision, a little bit of drawing some graphs and calculating some of these summary statistics, but most of the questions include one like this at the end, where you need to identify something that's a bit out of place. Thanks, guys.